So little baby wants to learn about organic chemistry. Oh my god. They grow up so fast. Okay, let's begin. This is a ball. A ball. This ball, can you see it? This ball can stick to two other balls. So this ball can stick to two other balls. Yeah, it can. This ball can stick to three others. This ball can stick to three others. Because they have chemistry together. That's why they have so much chemistry. And this ball can stick to four others. Four other balls. Each type of ball. Each type of ball. So we've got tiny blue, green, yellow, red. Can stick to a certain number of other balls. So these two balls can stick to each other, so it's one other. This big one can stick to two others. This yellow one can stick to three others. Yellow is 3, obviously. Green is 2, and red is 4. So 1, 2, 3, 4. My stomach is grumbling. Imagine all the shapes that we can make, connecting all of these balls together. Isn't that a pretty little picture? We have a red ball, which can stick to 4. So we have all 1, 2, 3, 4, 5, 6, 6 balls with 4 balls each sticking together. They can stick together just by combining these balls. So, for example, we have one blue ball because it's a green ball, 2 balls. So that'll connect to a ball of 4 because they'll share one of the blue balls. So then you just make a little connection. We have a green one, a blue, a red one, red, 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 and then a yellow one. The yellow one has 2 extra balls because they're using one of the other balls to connect to the bigger one. So you can make a little chain link connecting them with the tiny ones. These balls are like atoms. Atoms make up everything. So, as you can see, these balls are like atoms. Atoms make up everything. So as they start to build, they'll start to make up everything. Each type of atom can stick to a certain number of other atoms, as already covered. The balls were. This is the carbon atom. It is very special. The red one that could connect to 4 is the carbon atom. Carbon can connect to 4. It can stick to 4 other atoms. The blue pieces were atoms. So the carbon can have 4 atoms. 4 atoms can connect to the carbon. So, and it sticks very well. So right now we have dimethylamine. So we have dimethylamine. We have dimethylamine. We also have methanediol, methanediol. This one right there, that connected, and we also have methanol right here. And it likes to make big shapes. All of these carbon atoms, carbon molecules connected to atoms. These shapes are called organic molecules. Organic molecules. There are many organic molecules like benzene, butane, and ethanol. heparin. We have all of these different atoms that then make up the molecule. Some are medicines. We also have vanillin. Some smell really nice. So they're all just bonded together. They all just like each other. We have cotton, which is like a bunch of these, a lot of these. And then we have amylose, which is a bunch of these, a bunch of these. And then we have sodium laurate, which is like soap, and it's like a bunch of these, but it's like all organized in a temple. And then we have histidine, which is like all of this. It's this cheese. Organic molecules are found everywhere. We also have heptane, which is this long one too. And we have isooctane, isooctane, which is like this huge one right here too. Gasoline contains lots of organic molecules because they're fossils that were essentially turned into fossil fuel. But there's a lot of organic molecules to it. Did you know, little baby, did you know, little baby, that there was a man who made a water-powered car? Yeah, there was a man who made a water-powered car, meaning that you could drive your car using just water. He's dead now. Plants contain lots of organic molecules, lots of them, like chlorophyll, which is like all of that. Look at that. That's like a lot of organic molecules because it's an organic leaf. Shh, silence yourself. Silence yourself. I will have no back talk from you. Please. No, don't speak back. Just no. Stop complaining. No moaning. No moaning. Silly. So, we have all of these organic molecules that then make up this organic leaf. Yeah. And then we also have glucose. Glucose is also an organic molecule. And it's plant material. It's made up of a lot of organic molecules. And it's right up here. Right up here. So organic means like natural. It means like, you know, it's basically found in nature. Even you contain lots of organic molecules. Even you contain lots of organic molecules. You, because you are an organic being. So you have glutathione, 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 glutathione. You also have adenine and acetone. Acetone is acetone. So this girl right here has acetone, adenine, and glutathione. All life on Earth has organic molecules, and all life on Earth needs carbon. We need carbon on Earth, all of us, because that's what we need to exist. Now you know organic chemistry. So, let's recap. What have we learned in our lesson today? The nature of atoms, very good, and what are molecules? Very good, very good. And how do molecules bond to each other? Through atoms, very good. And why is it called organic chemistry and not just chemistry? Because it's made up of organic materials, things that you find in nature on Earth. Very good. Very good. Okay. I'm going to put this one to the side. You learned so much today. And I am so proud. You have such a big brain. Let me just get a little bit of this organic material off your face. You've learned so much today, and I am so proud. You've captured all of the information that we've covered today, and now I'm going to leave you to just internalize it, settle it in, and perhaps explore more of that information for yourself, okay? Remember, science and chemistry are very, very important. That's how we can describe the things that we see in nature or happen in the world, okay? Sweet dreams.